this mic on here is mine. Okay, so thank you, Joachim. Distinguished, I don't know, but I have been doing this stuff for a while. Mostly at University College London, where I joined in 1996. And yes, we are in the centre of London. But last year I was on sabbatical, so some of this thinking got refined last year while I was away. The first 6 months I was at Microsoft in Redmond, working with Ken Hinckley and the VR group there. That was quite inspiring. I did some new things for me, built some hardware, which I'll be reading about in the next year or so when we finally get around to writing it up. And also having a great time talking about neuroscience and some of these ideas, which I'll talk about. And then for the second 6 months, I was actually quite close by. I was in Christchurch in New Zealand for 6 months at the HIT Lab, and that was more relaxing than being at Microsoft, that's for certain. Also a lovely part of the world, and I did manage to make it to Australia. So my first time in Australia was earlier this year, and my second time now. So I have a simple premise for you today, which is that collaboration in immersive virtual reality is good, but could be better. And that's one of our main challenges at the moment, is that there's a lot of consumer systems out there. They're great. It's 95% games. And I love games, right? My students love games. I will happily challenge you to some of those games. Not Beat Saber, though. I'm terrible at Beat Saber. But collaboration is really, for me, the huge opportunity, and it always has been one of the main things that my group has studied. The opportunity is huge, absolutely huge, to improve lives, reduce carbon footprints, increase accessibility, and I'm happy, and you'll be hearing about a workshop that we're going to hold at the next IEEE VR conference. I'm trying to get really serious about holding virtual reality conferences. We've always done that over the years. There's been ones. I did my first long-term 3-day conference in a conference called Avatars, which was 1997, I think. The technology has improved, and I think our community should be eating its own dog food and really trying to do that. And there are little bits. US had a great workshop attempt at this, and Kai has had telepresence robots for years, so I think we can do a lot there. But go back to the first line. The premise is that it could be a lot better, and it can be great to collaborate and great to socialise in these spaces. We can have more of the experience of being at conferences throughout our working lives and improve our research careers and research our own working lives. So the argument that was the premise. The argument is that is quite straightforward. The collaboration in immersive virtual is good, but hasn't really changed since the 1990s. And I'm quite glad Jackie's here, because when she talks about avatars and we hear her talk, that's going to be a little bit controversial, my statement, because things have visually changed. They've got better, but there's elements which I think haven't changed. Now, my group is mostly known for work on presence and the associated technologies since the 1990s. And I will apologise in advance for the questionnaire, because it's useful and not useful at the same time. But what we've learned is mostly really to not focus on it anymore. Presence as a concept is quite motivating. It's really possibly the unique thing about immersive virtual reality, the feeling that you're there, but really you can look past it. It's a sort of threshold concept. It's either there or it isn't. And what gets interesting is what you can do with yourself while you're there. And it's a concept called embodied cognition, which I'll talk about, and how we've tried to tie that into virtual reality. And then the third part will really look at what we're doing recently, that this theory, these tools of embodied cognition, give us a way of studying virtual reality, which we've just taken some baby steps towards trying to get a handle and I'll talk about two recent experiments there. And that's this area, which is a recent area called embodied social cognition. The main idea is that we use our bodies to communicate, and we don't just do that through verbal and non-verbal communication. We change space and our relationship with it to communicate, and people understand that quite quite unconsciously. And when some companies make avatars that stop down here, my claim is that you're missing something, and that's where we'll end up. Obviously, you're missing your legs, literally. But the final experiment is about feet, and I'm trying to convince you that feet are important. Okay, so let's talk about collaboration. Now, this first part was really just to point out it's old work, and an experiment I love talking about, which is from 1999. So it's celebrating its 20th anniversary. This experiment, but it's an immersive collaboration experiment. So it's done between two cave-like displays. So one of which is 4 walls and a floor. That one is in Gothenburg, and one which is 3 walls and a floor and is in my lab in London. So the premise is that we get people in and we get them to do tasks. And I'm a big fan of puzzles. It's you don't want to know how many boxes full of these things I have in the loft. But the idea is that two people are solving a sort of 3D jigsaw puzzle. It looks a little bit like a Rubik's Cube when it's finished. It's actually not a Rubik's Cube puzzle because of the bits come apart. And there are 8 bits that you have to pick up, move around and stick together. The reason for using this task is that you can do it with physical blocks. So various PhD students have got their craft knives out and made these things over the years, and also studied how people solve this in the real world. These avatars are quite simple. At the time we had head trackers and hand trackers. Not much has changed there. We only had one hand tracker though, so the left arm in each case is static. And then there's a kinematic. It's very simple kinematics for the body, so the arm moves around. So although those are crude, they're crude by design. We sort of have examples where we've got programmer art for making things that look more realistic, and most people hate them, so we don't use them. And these ones are affectionately known as the Batman versions with the bat pants on the outside. Don't ask me why. The underwear is red. Wasn't my choice. Anyway, so you see them move around. And the key thing is you see the arm move, you see the other person move, and it gets quite simple. It gets quite easy to observe what's going on. The person on the left has got the gorilla arm effect because of the structure of the avatar. We just scale it. We don't do the knees. We just make it taller and shorter. So they haven't got short. They've just crouched down to look underneath. And all of that is quite natural. And these days, nobody's surprised. I don't have to explain to people that it's an immersive system. So if you crouch, people just do that naturally. We don't have to tell them to crouch down. They just do it, and that helps them solve this task. In fact, it's a little bit cheating because in the real world that would be difficult. Because in the real world, the bottom would be on a table, and so here's the puzzle just about to be finished, and then there it is. Rounds of applause for everybody. So, so this task is already quite compelling from a user interface point of view. Here's something which didn't really work in software, in that we didn't anticipate it happening. But this is a view of our cave looking into it. I'll play it twice. You see scan lines. You see everything a bit fuzzy because it's filmed on we didn't crop out the stereo view for the camera. And you see the two people collaborating and moving around. And the thing that you see there, which is quite complicated and quite surprising, is something we didn't actually program, which is the other person picking up that cube with the blue face there, and then handing it to this person, who then puts it where they're supposed to go. They walk through it. We'll ignore that for the moment. But they then put that in the place they go. So the person, if you listen to the dialogue, which does need a separate video, what you'll hear is the person saying that, oh, I've got, this cube I've got goes over there, and they're talking about space very fluently, and they pick it up and hand it to them. Notice they don't hand it very far; they just pick it up. The person could reach it. They're just saying this is the one, and they're signaling that by passing it. And the thing that we didn't program is that actually they can hand it from one to the other. That is actually a race condition in the software, but fortunately the first person let go of it fast enough that it didn't start flickering between the two. So from a social point of view, this is a really already quite complicated situation. The people are talking very fluently about the space. They're talking about where things go. They're discussing things that they can't see, but the other person can see. And that's really interesting. Now, the headline figures, though, for those of you who like numbers, are that we compared, there are a series of PhD theses about this. This study's been, this type of study has been run hundreds of times. So here's one study. The main point is that, as I said, you can take these cubes and make them make physical versions of them. They're 30 centimeters on each side, and you can have two people do this on a table. If you do that, then you get a performance that looks like the red line. And to explain that, this task is relatively hard. It's not straightforward. It looks simple, but it's actually every piece is ambiguous. So there are only a few ways to actually solve it. And each cubelet, the little ones, have 4 coloured faces, though only 3 are visible on the outside. So the key thing is that not everybody finishes. If you give a couple, a pair, 20 minutes, you'll see that in the real world, 95% of them finish. And this is a cumulative completion graph, so it always trends monotonically up. The first couple in the real world finish after 3 minutes, then there's a couple after 4 minutes, and so on. So that the performance in the real world is sort of a benchmark. And if you get 2 caves and 2 people that can move around with one arm behind their back, to be honest, and do the same task, then the effective performance is not really any different. So they perform it in the cave, and then they can, you see that it goes over 80% completion rate. And before you get to about 10 minutes, they're very hard to tell apart, those graphs. So that's really interesting. It's showing that somehow the collaboration in immersive virtual reality of the time was successful for this measure, which is obviously quite limited. The graph at the bottom, though, is quite interesting and is an issue which I'll flag but won't talk too much about, which is that if you have one person in the cave and one person on a desktop, the performance is appalling. In fact, in another study, if you have 2 people on 2 desktops, it's better than that. So it's not just the form of the interface on the desktop being inefficient for manipulating the cubes, it's just the way in which they interact. For example, one of the phenomena we saw in this study is that the person in the cave gets up close and manipulates things like this, because that's how the interaction technique works. But the person in the desktop takes a step back so they can see everything. So they're just further away. They look less engaged with the task. So they see it over there, and they manipulate things with a mouse, and it just looks like they're less engaged. And that sort of technical imbalance means that actually there becomes a social imbalance, that the person in the cave thinks the other person isn't helping, and therefore starts doing it on their own, because they're not, they think the other person is just going to stand back. And it's very hard to coordinate on tasks, and that handover between 2 people is obviously almost impossible. Now that's very relevant because, of course, right now we have lots of immersive systems. I'll pick on the one from Microsoft So the immersive systems like AltSpace, which have immersive displays, and they have desktop displays, and they have people collaborate. And there's no surprise that they see this phenomena happen in those systems as well. That it's a bit of asymmetry to the collaboration, and so that's a major challenge for the field. Is people will want to use non-immersive interfaces and pretend that they're an avatar, or not pretend, be shown as an avatar and collaborate, but there'll be an asymmetry there because the key theory from this is that the interfaces are asymmetric, so that the people don't understand how the other person will interact in the same way that they do, and therefore that means that they don't understand what tasks are going to be slow and fast for you, and therefore they give you the wrong tasks to do. Well, they partition up the task in a slightly different way. Okay, okay, that is one of my favourite experiments. I talked a little bit too long. Just to bring that right up to date, so one of the things I showed you in the previous study was about the social response. We ran studies that followed that up, where we had people work on tasks for whole days, like 8 hours in the VR system. And this was back in the early 2000s. And you had to do that in a cave at the time, otherwise they'd be ill. But all these interesting social phenomena. So we have kept on doing that type of social, just the study of the tasks. And this paper was presented at VRST last year, and it's a study with the Oculus Rooms toolkit, done with the help of Oculus, who have an office in London, not too far away from my office. And we do occasionally fight for some of the same staff. And that was more longitudinal, so the avatars in the previous study were really, you couldn't choose, but one of the phenomena in the sort of social VR systems that we have now are that you can choose an avatar, but it's usually a constrained choice. In Oculus Rooms at the time, you could have a brightly coloured, monochromatic avatar, and a few choices. And also it's Facebook, so the gestures are limited. So this is just one thing from that paper. This was a study of groups for months going through the social experience of using the virtual reality. What do they do? This is a screenshot from a meeting of four friends who'd recently graduated from university. These friends were usually, when they were students, would meet in the pub. They were incredibly rude to each other, and Facebook, they could use the words, but not the gestures. So there's a lovely anecdote which apparently is quite doing the round, being quite influential inside Facebook. This gesture they appropriated as being the middle finger gesture. So because the Gear VR at the time, when you tap the side of the helmet, that was it would show your avatar doing this. And in the UK, occasionally this means you're a bit crazy. That gesture doesn't travel very far, across the world. But they meant it as the middle finger gesture, and because Facebook wouldn't allow them the middle finger gesture. So those phenomena are sort of really interesting. And I can talk a little bit more about that afterwards with anybody that's interested. The form of the avatars was quite complicated. We had people, like good friends, who couldn't talk to each other because the avatars didn't look like the other person. And I had good friends who couldn't care less about the form of the avatar. And that's where, that's a branch off from this talk. Is it seems to me matter that it look exactly like the person you're expecting for some people some of the time, not everybody all of the time. So we have to be a little cautious about saying that we're going to start modeling the avatar from the face on the HMD. Definitely appropriate some of the time, but people use this for a few hours a week for months and had a great time. The four friends in particular that were former university colleagues said that it was almost as good as going to the pub without alcohol, but almost as good as going to the pub. So bring your own alcohol. Okay. Right. So I'll skip over one and then talk about embodied cognition. So I downplayed the importance of presence and the idea that you're immersed in this space. I think we just take that as a given now. Sometimes it was used as a defense against people talking about non-immersive things as being virtual reality. But this idea of embodied cognition has obviously had quite a lot of influence in neuroscience, and I came to it through a paper in linguistics that was about the teaching of maths, and the key premise of the paper that we modelled this on was that children and adults were worse at maths if they sat on their hands. And I'll explain that in a second. Right. So I have a task for you. Right, we're going to do the experiment. Apologies for those of you who were in VRST earlier in the week who've done this. So the experiment is quite straightforward, and I'll do it with the timing we use in the experiment, just to convey that it is quite a lot of load. So the idea is this, just to reassure you, is that you're not supposed to be able to do it perfectly. Okay, right. So you have 15 seconds to memorize the following letter pairs. Okay. Right. Which of the lower four figures are rotated versions of the upper? Please tell me which of the two on the bottom are rotated versions of the upper ones. You can shout out. Or I can tell you it's A and B. Thank you. Yes. Right. Please tell me the 8 letters.
CF, my BF, BB.
If you all say the whole alphabet, I'll have to assume that everybody got it right. Okay, right. So the point, right, is that this is a standard test of spatial reasoning. Okay, I forgot what it's called actually, but it's relatively hard. But most people, this audience, I'd expect most people to be able to do that. But it's got time pressure on it, right? So the success rate about 85% through 90%, I would expect. Though it's obviously very individually variable. This is hard, right? So remembering 8 letters is quite hard. And the 2 tasks interfere. So the premise is, the experiment is, if you find this easy or hard, you'll remember fewer letters. Okay? So the paper in linguistics had done the same protocol, but instead of doing rotations, they'd done factoring of quadratic equations. Okay? Which is great for high school students who've just been taught it. I think some of my undergraduates would have forgotten, despite being in computer science. But the idea is, the premise of their study is that their study, which I don't have figures from their study, is if you sit on your hands, you're worse at it. Right, but at doing the maths, right, and remembering the letters. We reproduce that in the VR, which is that the avatar sits there. You can't sit on your hands. They have trackers attached to them. It would be painful. But we just make you put your hands on your legs, right? So keep your hands stationary under a table. And they compared that to moving your hands around. And the thing is, if you're factoring equations, and as I gesture, you'll know exactly. You'll hopefully be able to interpret a little bit of what I say. That there's a long equation and there's 2 short bits. Long, 2 short. The task is to find these 2 numbers and these 2 numbers from the upper 3 numbers, right? So even that gesturing helps me a little bit, possibly even helps you a little bit remember what quadratic equations were. So the premise from the embodied cognition is that's not a side effect of thinking. Gesture is not a side effect, it is thinking. It is part of the process, it's essential, and the reason I was interested in it is because schools at the time in the UK had this big anti-fidgeting thing, and they were forcing kids to keep their hands stationary and not fidget, not doodle. And lots of people I knew teaching maths said that, well, if you watch a mathematician doing maths, some of them are doodling all the time, right? It's what they do, and some of those doodles are helping them do the task. So with this one, it's sort of more obvious. You can imagine that if you're having to rotate, and I didn't see anybody obviously doing this, but then in the experiment, you see people do this. They move their mental model by moving their hands. Okay? And there's another obvious thing that they do, which is it's not C, and they just put their hand down on C and they cover it up. So they don't have to think about two things anymore. They have to only think about four things. They can ignore C because they're determined it's not C, and they're a bit confused about B. A is obvious, or maybe they put their hand under B, saying I'm not confused about this one. So the moving their hands is helping them change the world to marshal their thoughts, and that's quite a strong theme now in neuroscience work. So our study, we basically we reproduced that with these two cases. Just to see if the same thing worked in virtual reality or not. And then we just did it without an avatar. So we have two conditions. One is where they don't have a self-avatar. Neither of them has a self-avatar. One can gesture and one can't. The results, to jump to those, are that the spatial orientation task has no difference across it. Okay, so the rotating things doesn't have an impact. But if you don't have if you have an avatar and you're allowed to move it, you recall significantly more letters than if you have an avatar and you aren't allowed to move it. So that reproduces the paper from Golden Meadow et al. In linguistics. And if you don't have an avatar, it's just down there at the bottom, right? So it's no different than having an avatar and not being allowed to move it. And I'm afraid I've taken out the slide, but there's another interesting phenomena, which is that if somebody doesn't have an avatar or has an avatar, but they can gesture, they don't. And that's actually quite useful from the neuroscience point of view, because it sort of more strongly suggests that the gesturing isn't a side effect, because it stops if you can't see your hands. So what we see is some people, they start gesturing and then they stop. And actually the number of times that people actually gestured when they couldn't see their avatar was very, very low. It's less than 5% or less than 10%, which is really fascinating, because they're doing the same task, right? So somehow this convinces me, at least, that it's important to see an avatar. Right. The obvious question is, what avatar? This was reported earlier in the week. This is, and also we got, so this is the most common type of avatar you see in a consumer VR system. Is two hands that aren't connected to your body, and they stop here. So they're visually quite confusing when you look at the ends of them, because you've never seen the end of your wrist before. So you could think about, does it need to look like me? Does it need to be connected to my body? We didn't animate the body. We're in this quite constrained situation where they sit at a desk, so we know a lot about the avatar from the head position and the hand position. Also, we have the table, so it's all constrained, so the hands rest on the table. It's a nice constraint, which I think is actually more important than we thought when we designed the experiment. Is when you feel your hands on the table, you see them on the table, and they don't penetrate the table. They don't hover above the table. They sit on the table. We took one look at the experiment after a student originally implemented it, and I just said, you just got to do all of that inverse kinematics for every finger, because it just looks odd if your finger's above the table. So that is mentioned in the paper, but it's something that some people that have looked at this haven't really considered. Is, if your fingers go through the table, it's going to feel odd, or you might get an interesting odd response. And then on the right, we obviously have people doing it for real. You can it's interesting. This is not an interactive task. It's not. It doesn't really emphasise the virtual reality that much. You can do it with a piece of paper on a table, and you can see somebody doing it on the table there, wearing the hand tracker so we can measure the amount of gesture and also to make it as similar as possible to the virtual situation. And the results for that are little confusing, or a little not so cut and dry. The full avatar and the real are both distinct, significantly different than the no avatar, but the hands only is not different from any of the others. So that's interesting. And if you look at the gesturing again, what you'll find is that people with the full avatar and the real, they gesture all the time. People without an avatar don't gesture, or gesture very rarely because they can't see it. That's the same as the previous experiment. And wonderfully, the people with only see the hands gesture about half the time. Now, unfortunately, your first question will be, is that dependent on an individual person? And it's a complete failure in the protocol, but we actually don't know how to associate that to individual people. It's just a mistake we made when we did the protocol, and when we run it again, I'll be able to tell you. But my gut feeling, and the person of Yi Pan who helped me with this, is that it was that some people just gestures all the time and some people didn't. And so that avatar, again, hinting at these hands may work for some people, but not others. We did have male and female, by the way, so that it wasn't you just had a big clunky hand, but we didn't size it to the person. It was in the right place, obviously, but it wasn't. We didn't customize it. Okay, so the turning point then is that was about individuals. They know about their bodies. They're using it, and they're gesturing automatically. So it's sort of obvious. Obviously, people have been, since immersive collaborative systems existed, have said, well, non-verbal communication is important, right? But it's sort of now obvious that non-verbal communication is not targeted communication. But if I see you doing these gestures, I can infer what you're thinking, and I can ask certain questions about you watching videos of people doing that, and we might find more information than we might think. So the turn is, how can we can we find ways of seeing how that impacts on collaborative tasks? So this is a recent study that we're again with Yi Pan, where we had people solving jigsaws, puzzles again. I love puzzles. So they solve puzzles like this. They're quite simple. Each of them has 16 pieces. There's 2 puzzles in a room. The room is modelled on a real room, a lab we used to have. You put the pieces together. There's a word on it and a picture of the thing which is you're trying to build. In this case, it's fly. There are 2 puzzles. There's a word on the other one, and the 2 short words make one word. The other word in this case is butter, and the goal of the task is to say out loud butterfly, not fly butter. Butterfly is the right answer. So you do that with 2 people, and here's a snapshot from the system. There's 2 people. They're headless. I have to point this out. They're headless because, of course, you don't render your own head in a head-mounted display. You don't want to see the inside of it, the eyeballs, the mouth, and the chest. So on the left is the view of the green person. There's no head in it. I have got asked if it was supposed to be Halloween or something like that, but no, this is how it's supposed to be. And so there's 2 views. On the right is the view of the person in pink. So there's no head on the left on that avatar. So the key thing here is this is a protocol which I think is quite interesting, and is actually applicable to a lot of different collaborative VR systems. So I'm recommending it to people. So pairs of people are cooperating or competing. They're either doing this by meeting physically, they're doing it with avatars, or they're doing it with just views of controllers. And the thing which I think is interesting is using trust measured by an investment game. So, right, so I'll come back to this, but the idea is that people have to bet in an investment game after they perform the task. The betting goes in the investment goes in 5 rounds, and this is a sort of standard economics test of trust. It's one very narrow definition of trust, I admit, right? But it's whether or not you're willing to invest money so everybody makes money. So it's not quite like prisoner's dilemma, but if you know what prisoner's dilemma is, there's an advantage to everybody throwing all their money in, but you've really got to trust them to do that. And the idea is that trust goes up over time because you know them, and you can use this as a measure of gain of trust over time. So the rounds happen immediately, the betting is sequential, then you do some VR, then you do it again, then you do some VR, then you do it again. Okay. Okay, so right. I'll go to this and I'll come back. So every pair competed to solve this task, and every pair cooperated to solve this task. So if I had slightly more time, I would ask you lot, are these pair competing or collaborating? They're collaborating. And what's the social signals of that? And it's sort of obvious. They are that they're standing next to each other, fully exposed. They can see the hands of the other person. They're helping each other. So the person on the right is holding a piece which goes into the jigsaw. So it's the suggestion of which one to do next. And they're looking at the same thing. Right. Obviously, that's in the real world. Are these people collaborating or competing? So this is the my favourite image. Signals that they're competing are many. The person on the right has a gesture which, like this, which is very similar to this, and means that I could turn very slowly, very quickly, and you can't see that I'm looking at you where I'm looking. So it's a sort of, I'm trying to hide my eye gaze, and you're not really, I'm not really trying to peek around your shoulder. The person on the left is using their body as a shield. They're standing in their line of sight. So the words are gold and fish. You can just about see fish being constructed on the left, but you can't see gold anymore because the person on the right found gold, then took all the pieces apart, stacked them up, and there's no letters at all visible. So made it very hard now for the other person to see what they're doing. So. The key point is, and this is my favourite part of this study, is you see this body shielding going on in the virtual world as well. So here's one of the avatars, different puzzle at the moment, moving the controllers around, solving the pieces of puzzle, and then using her body to shield the view of the other head-mounted display user. So that's the easy takeaway, is that we didn't tell them they could do that. It's sort of natural to do it, and hence the point at the start about the form of the avatar being important, because in this situation, it's important that you have a solid body down to at least the waist, because you want it to obscure information. So to go back to the other results, what we found is that people are able to trust each other more quickly using avatars. And I'm afraid I'll have to wave some hands at this point because I only have a few minutes left. Okay. So the very final thing then on the sort of experiment side is feet. So we were looking for motivation. So this has just come out a couple of weeks ago. What about full body kinematics? Is it necessary for these types of tasks? It's a lot of work. There are a lot of people trying. It's not a consumer technology yet. There are various people trying to stick cameras in head-mounted displays pointing down and then use computer vision to track your body. So maybe it'll become a consumer technology in a couple of years. Certainly, the experience with the lighthouse has been that not many people are willing to put cameras up in their environments, especially their domestic environments, to do that. So that's a bit of a challenge if that's the only way we're going to be able to do it. And then the suits and things you strap on has to be a bit of a motivation for that. So we would just ask the basic question, what about the feet? And so we ran a very similar study as the puzzle solving one. It's only cooperative this time, so it's slightly simpler. And on the left you see a sort of top-down version of the environment. And what's happening now is that there are two versions of the avatar. One which has foot tracking enabled using Vive pucks, and the other one which just has the body dangle from an approximation of where we think the centre of your neck is. And the centre of your neck dangling is the default thing if you go for a full body avatar at the moment. And yeah, so we're interested in how. It's a social situation, it's jigsaw puzzles again. I'm trying to get at this, what's the inadvertent effect? Obviously you can make a task where the feet are important, just make it football, right? This is a task where the feet are not important for the task, but we're interested in the social impact of them. So they have to solve puzzles again. There's a theme. It's very similar to the same puzzles actually. They just have to assemble them, there's no words on them this time. But they're dotted around the environment, and you have to reach over and get them. So, in particular, if you look on the left, sometimes they're on shelves, and you can see what happens on the left. This is with the tracking on. You've got foot tracking, arm tracking, head tracking, and they are able to reach over. And you can imagine that in the other mode, the feet would then go and stand on the plants. I'm afraid I don't have a video of that. So yeah, it's very. You see the person picking up the pieces. You might want to tell them where to go, and then you see them standing and reaching. But there's these flower pots on the floor which their feet may collide with. Okay, so the main result is that the feet make no impact on the task completion time. Because it's based on the hands, right? I mean, you can pick up the pieces. If you're focused on the task, you pick up the pieces. But they make a very significant impact on where they stand. And this is what now the work will head away and try and analyse, is tasks where it's very important you know exactly where they are so that you can communicate with them more effectively. So the plots here are a little bit confusing, but if you've got no avatar, you can see that people will just wander over the boundaries. So they wander into the shelves on the left. You can see a series of dots and lines on the left. And it generally looks a bit bigger. That's because they're walking around and colliding with things. They have an avatar with the floating feet. You see that it's very similar to one on the right, but the one on the right, you'll notice that they stand between the flower pots a lot more. And this is one of the analysis that we were planning, was if you look at the right-hand part of this graph, they don't have an avatar. They stand nowhere near they stand on the plants. If they have floating feet, they don't stand close to them very often. In fact, anecdotally, they tend to stand away and lean a lot further. They won't walk near those things because maybe they feel as if their feet will collide with them. And if they're tracked, then they're much more likely to stand right in between and very close to the object. So that's interesting. It hints that the feet are important, and especially in cluttered environments. Or if you need to know exactly what their attitude is towards an object. So you can imagine follow-on studies where it's not just important that they solve a task in one place, but in lots of different places around in a control room or a training scenario where it's important to know that they are close to a place or at least attending to it or ready to interact with something. And if they're not going to stand close to it because their feet are floating, then that's going to give the wrong signal. Okay, so I think I'll wrap up there because I think we want lots of time for questions. The summary is really that the virtual body is not we used to think of it as just an indicator of location, focus of attention, behavior, emotional state, but it's really a resource to reason about cognitive state, both your own and the other person's. So not just communication, but but their state, that you inferring what they're thinking, what they're doing, and hopefully I convince you that that is true for these sort of trust building. I showed you two experiments, one with trust building, and then this little one. This is a bit simpler, which is about where they stand in the environment based on the tracking. The full body tracking, I think, still think it's a high barrier, right? It's difficult to convince people to focus to invest all that time and technology in building it. But I think we're currently looking for more indication that the body is important in other situations. So in particular, we're looking more at trust and attitude towards people. So we've run other experiments. We do quite a lot of work on robotics and avatar embodiment and so on, where the focus has been trusting a very specific representation when it's gesturing. And I think we'll try and merge those together and come up with tasks where it's about subtle things like body shift when you're looking at them. And the final thing, and one of the things I've been focusing on last year, is more finesse. Beat Saber is great, right? But it's big scale gestures, and I'm really interested in this. I'm interested in puzzles. I don't solve Rubik's Cubes very much, but it's very interesting the amount of finesse people have in interaction with their hands. And we're doing very poorly. We're getting people to hold big sticks at the moment. We've got hand robots, and I'm really interested in what you do with your fingers to do maths or to do tasks. And I think that getting that finesse in is a real challenge, and I'm happy to talk more about what exactly I mean there. Okay, thank you.
So we have time for some questions. I guess you can talk to the cube.
So thank you for the talk, really inspiring stuff. I've just got a question about the experiment you did with having a full body avatar compared to having just the floating hands, and whether there was a test done for if there's any improvement over time with the hands. Because one of the things we notice in designing narrative is there's always an acclimation period, or if you have a new locomotion method, there's this acclimation period. And I was just curious if that was tested over time.
It's a very good question, and we have acclimatization periods within the experiments. So if you look at the detail in the paper, and it's one slide with it on, they practice a bit, and then we wait for a steady state on the task they're doing, and then we measure them. But yes, if somebody's used these for 10, 20 hours, they may get quite used to seeing their end of the hand. So that's a great question. It's just very hard to study in the lab. We are trying to do more sort of out in the wild studies. We have one which we have published, an experiment you can do online. But we, for various reasons, including the General Data Protection Act in Europe, we're not getting people to come back multiple times because we have to still persuade our ethics committee that we can gather longitudinal data anonymously, because it's quite revealing. We can't claim it's anonymous. So yeah, it's a great question, and we have talked about trying to study games players and then maybe get them in before and after, and then study them. But yeah, I can imagine that some of this would go down, but some of it would hopefully stay. Like the feet, it's a social signal. Where am I standing? What am I looking at? Am I really close to Joachim, or am I standing an extra 10 centimetres away simply because I don't know where my feet are? So we'd hope that we could get that back again, right? He's from the south of Europe, I'm from the north of Europe, and you should be able to tell that from this distance, right? That's well known. That's well known. Statistics on that, and if we're biasing it by 10 centimeters, that's easy to remove. So hopefully, yes, you're right, they could acclimatise, but hopefully we can hopefully get them acclimatised to something which is appropriate, or at least they can work with. I'm also very interested in customisation of these things. So if I'm going to invest a lot of time in line, I want to have control over what I do, and that's obviously not negotiable at the moment with the way in which applications are served to us. So I get the avatar they say, oh, I can choose between. And actually, I might invest a lot of time in getting used to one, and that's a big challenge as well.
More questions?
Great talk. I'm just wondering if you've done, or if anyone's done studies with professional body movers, so dancers, acrobats, martial artists, things like that, and how they move with avatars.
Yes, so we have a separate theme of work where we've studied telecollaboration systems, so telepresence systems and robots and so on. We've used actors. We're next to an acting school in UCL. And yes, if you get a professional, a professional communicator to use them, they're very successful. They learn the limitations quite quickly. And if they don't have feet, then they just figure out another way of doing it, because that's like a challenge, like a studio challenge for them. Do this, but sat, or do the. They struggle with the faces though. So that's even if the face has no purpose, they don't like having. And we do tasks like the jigsaw solving where it doesn't have a purpose. They are quite focused on that. So that's maybe not for dancers. I'm going to work with dancers, but we haven't yet. But that sort of control of the face is quite hard. We have ourselves tried motion capture systems and gesturing for faces, and they hate it. They can use it. They're professionals. They can use it, whatever you give them, right? That's also one of the reasons we use them. You say, go and use this, wear all of this, and stand right there and do it. They're professionals, right? They will do what you. It's just like being in a TV studio. They have struggled with non-control of the face as a sort of side channel to the other person, or as the main objective. Yeah. And as I said, we've done face tracking and it's not worked for them. They've not found it very rich. So yeah, that's again a big challenge. With a lot of computer vision people focusing on faces, and they're not having the same conversation, which I try and get them interested in, is, get an actor in and get somebody who rates actors to rate acting.
Great talk, Anthony. I have a question about the personal experience I had with VR theater last year at Tokyo at SIGGRAPH Asia. So I was enjoying VR theater for like 5 minutes, and then I suddenly started feeling weird, like depression, suddenly, some kind of, it was very weird. And I asked them to stop it right away. Mm-hmm. And then I realized that it was happening because I couldn't realize that I'm there because I couldn't see my feet at all. Because I was trying to look down, I couldn't see my feet, so I put a finger in the headset so that I can come back to the reality that I'm not really. It was a very immersive experience, pretty good, awesome, but it kind of it separated me, like decoupled me from the reality. So I don't know if these kind of experiments you're also trying to perform, where you can actually also study how users would feel when some parts of the body are not there, with the VR experience.
Yeah, so the first thing is that I think a lot of people have the same experience. Look down, don't see anybody, and go, where am I? And then they have a completely different level, almost, of skepticism towards the rest of the environment, in that they are your worst critic because you've told them something which is definitely not true, which is you're not there. I'm very interested in the thing about, you noticed it after 5 minutes. that class of behaviour I'm really interested in, because it should have an obvious behavioural signature, and it wasn't important until then, and now it's important, and now it's the thing that's wrong. And next time somebody can say, for you, when you set your profile for all of these VR environments, you want to have the body because that's corporality is important. So people have studied that particular phenomenon. We used to call it breaks in presence. When we were just using questionnaires, people would go, well, that's great, but it's a questionnaire. It's words for a start, and it's at the end. Those two things, both of them, make the instrument itself not very effective, right? They have to verbalise, or at least write, and then and it's minutes later. So we try to study this. If somebody's engagement or agency changes over time, you can find a signature of engagement or agency changing over time. You could talk to a lot of developers and a lot of content creators. Don't have one. I mean, we have one when it's shocking, right? And I can tell if you're not reacting to a shocking event because I can measure a baseline of your heart rate response and then say, didn't even notice that plane crash because the heart rate didn't change. I can do that, but it's not easy to embody ecologically in our most experiences. But people have hypothesized that there's an event-related potential, for example, which you could do in EEG. You could notice if somebody was suddenly realise that they're sat in a theatre and actually they can't move their hands. It's brought them out. It's lack of suspension of disbelief has failed in some ways. Yeah. So that real time is up for grab. That real time measure of is somebody. Again, I would be hesitant to say is somebody present. But the way I would go is if somebody is engaging, where engaging can just be paying attention to the appropriate things and seeing if they're involved. Yeah.
Thank you.
Have you ever looked at the difference between the display of a hand and then versus the display? In a lot of systems, they just display the controller that you're holding, like the Oculus or a Tilt.
Yeah.
Just the stick, or combinations of both. Would that, the hand holding the device?
No, not directly. I mean, we have done both. We're running an experiment. You'll notice it. So when we've run these hand tracking ones, we've actually stuck controllers on the back of the hands, so it's open hands. They can flex their fingers. The fingers, you don't see them flex though. Too many bits of technology to keep working for a couple of weeks. But in the puzzle ones, they're holding the controller, and that's because we just need it to work all the time, and we need the button. So we never compared the two. The problem is that they are very tactile experiences of having something in your hand and having to wave it around. So I draw the body, and having to wear a controller, having to hold a controller. We draw the controller usually, but I can't say that you need to. I don't think that lots of people have studied unencumbered hands through other types of illusion, like ownership illusions, like body ownership illusions. I don't think anybody's yet done one where you're holding something, because that is sort of you should be able to get the same illusion. That's an easy final year project for somebody's student in the audience. Mine, if I get there first. But I think it would be interesting to ask if my gut feeling says if they're holding something, you've got to draw it, and they can't convince them that they have an empty hand. Partly because they'll put it through things, and then they'll get the wrong haptic feedback. Yeah. They're quite large. That's my main feedback to those controllers. We use the knuckles controller when we can because it sits out of the way, but again, that's still large.
Okay, any more questions? One more.
Yeah. I'm just wondering if you've had any looked at any formal studies or done them yourself, because we've just anecdotally found that sometimes if you look down in experience and see the wrong avatar, it's more disturbing than no avatar.
It depends what you mean by wrong avatar.
Dainty girl looking down and seeing big, hairy, meaty man.
Yes. So in various experiments, we have had people had a negative reaction to seeing the wrong avatar, but we haven't studied that specifically. Other people have studied other avatars and changing the skin colour, putting them in clothes and so on. So what a study I didn't talk about, we had people doing an arm ownership illusion, reaching out. We had male and female avatars. They were reaching out, doing a simple task, and then we threaten the hand and look for a sort of stress response. But we ran it in the middle of the summer, and the avatar had a jumper on, and several people mentioned the jumper, and one person said they couldn't interact with it because they just felt as if they should feel hot because they were wearing a jumper. So that's one line. I don't have any more statistics on that. It's just anecdotal, but it made them feel uncomfortable because they were feeling they should feel hot because they got a jumper on. So yes, that's a wrong avatar. So there's lots of evidence, I think, that some people are very sensitive to the avatar, but just some people just get on with it, and those are probably the people who are playing the games now. I feel, but I wouldn't want to state that too strongly.
Because to avoid it, we've put gloves on the avatar too sometimes.
Yeah.
Gloves, long sleeves, and that people found that much less disturbing.
Yes, yeah, that is, yeah, lots of dressing up of the hands. Yeah, we are running a study on that at the moment, dressing of the hands, and trying to see what impact that has. So they'll put something on before the study, and then they'll see it. That's the giveaway of the main premise. Yeah.
Thank you. So I have one or two questions of my own. All the time I was listening to your interesting talk, Anthony. I was saying, well, of course, feet are important. You mentioned proxemics.
Mm-hmm.
And that's one of the reasons why you want, if you approach a group of people and they turn their feet away from you, it means that you're not welcome to join the conversation. For instance, there you go. And the other, so for me, feet are important. And you focused on this idea of using cameras and computer vision, but I wonder if you could design types of sensors in conjunction with cameras and computer vision that could give you a plausible full body avatar.
I'll be looking to my colleagues about. So we, like many labs of a certain age, have all of these pieces of kit, things you strap on your feet, shoes with sensors in. We've got dishes you walk in, and they can reproduce motion and so on. I haven't found one of those yet. I think people would deploy at scale. Maybe if it gets to the point where you just once insert an IMU onto some shoelaces and then you forget about it and it's self-powering, then maybe that stage. And I know people are looking at trying to get self-powered IMUs. So they power themselves from they power themselves from movement, and so they sort of cull energy from movement. But I think they're still a few years off for that. So when it gets to that stage, and then people can put them in lots of components, or every pair of shoes will just come with an LED sticker like front. They give away the stickers like you get in marathon shoes and so on. And I think that'll be easier. Yeah.